Have you ever wondered how the spinning blades of a windmill can transform a gentle breeze into a powerful force? This isn't just any question, it's the opening to a world of science, history, and environmental impact. Let's talk about windmills. These towering structures have been a part of human history for centuries. From grinding grain in ancient Persia to pumping water in the American West, windmills have played a vital role in our survival. But they're more than historical relics. Today, they're at the forefront of a sustainable future, generating electricity from nothing more than the air that moves around us. Now, you may find yourself intrigued by these energy giants. How do they manage to capture the wind's power? What's the magic behind those spinning blades? Well, it's not magic at all, but a blend of engineering and ingenuity. To unravel this mystery, we must journey into the heart of a windmill. At first glance, a windmill might seem like a simple structure, but it's quite the technological marvel. Our journey into the anatomy of a windmill begins with the most visible part, the blades. These long, slender structures are specifically designed to catch the wind. They're often angled and shaped much like an airplane wing, with a curved front and flatter back. This design allows the wind to move faster over one side, creating lift and causing the blade to turn. Next, we have the rotor, the heart of the windmill, to which the blades are attached. As the blades spin, the rotor also turns, acting like a large gear. The rotor's role is to convert the kinetic energy of the moving blades into mechanical energy that can be used elsewhere. This mechanical energy is transferred down the shaft, a long metal rod that runs the length of the windmill. The shaft is directly connected to the rotor at one end, and at the other end, it's linked to the generator. As the shaft turns, it spins the generator, which is where the real magic happens. Now, the generator is our final stop on this tour of windmill anatomy. Inside the generator, we find another set of gears and a series of magnets and coils. As the shaft spins the generator, it causes these magnets to move around the coils, creating an electromagnetic field. This process, known as electromagnetic induction, generates electrical energy. And there you have it. The wind's kinetic energy, captured by the blades, converted to mechanical energy by the rotor and shaft, and finally transformed into electrical energy by the generator. It's a complex dance of physics and engineering, all happening in the quiet spinning of a windmill. Now that we understand the anatomy of a windmill, let's dive into how it works. Scene script. Wind is more than just a gentle breeze on a hot summer day. It's a powerful force that can be harnessed. Let's delve into the science behind wind power. It all begins with the sun. You see, the sun doesn't heat the earth evenly. The poles receive less heat than the equator, creating temperature differences. These differences generate air pressure variations, and as air moves from high-pressure areas to low-pressure areas, voila, we have wind. So how do we capture this energy? Enter windmills. These are not just picturesque structures dotting the countryside, they are power-generating behemoths. As the wind blows, it pushes against the blades of the windmill. This force turns the blades, which are connected to a main shaft that spins. This spinning shaft is connected to a generator, where the kinetic energy from the wind is converted into electrical energy. This process is akin to riding a bicycle. When you pedal, you're turning a shaft connected to the wheels. The harder you pedal, the faster the wheels turn, right? Now, imagine if your bicycle could capture that energy and convert it into electricity. That's what a windmill does, but on a much larger scale. Now, you might be thinking, well, that sounds straightforward enough, but hold on, wind isn't a constant source of energy. It doesn't blow at the same speed all the time, and sometimes it doesn't blow at all. So we need clever engineering and technology to maximize the efficiency of windmills. The design and placement of the blades, the height of the tower, the direction the windmill faces, all these factors play a role in harnessing the maximum power from the wind. Moreover, storing this energy for use when the wind isn't blowing is another challenge. This is where batteries and power grids come into play, storing excess energy produced on windy days for use during calm periods. As we can see, harnessing the power of the wind is not as simple as it first appears. Yet, with advances in technology and engineering, we are continually finding better ways to tap into this abundant and renewable source of energy. So how does a windmill turn the power of the wind into usable energy? Now that's a question that's been intriguing minds for centuries. Let's unravel this together. Imagine a windy day. You're standing before a colossal windmill, its blades spinning in a steady rhythm. Their rotation is the first step in the energy transformation process. The windmill's blades are shaped like airfoils, similar to an airplane wing. When the wind strikes, the airfoil shape causes the wind to push one side of the blade more than the other, creating lift and causing the blade to turn. This is a brilliant application of Bernoulli's principle. Now, this rotational energy doesn't just stay in the blades, it's transferred down a shaft to a gearbox within the nacelle, the large structure at the top of the windmill. This gearbox is a mechanical wonder. It increases the speed of the rotation, making it suitable for the generator that comes next. The generator is where the magic happens. Inside, there are magnets and coils of wire. As the magnets spin with the shaft's rotation, they create a changing magnetic field. The coils of wire in this changing magnetic field experience a phenomenon known as electromagnetic induction. Simply put, the changing magnetic field causes electrons in the wire to move, creating electrical energy. This is where the law of conservation of energy comes into play. The wind's kinetic energy is transformed into mechanical energy by the turning blades, and then into electrical energy by the generator. None of the energy is lost, it's merely changed from one form to another. Once the electricity is generated, it's sent down the tower and into the grid, or stored in batteries for later use. And just like that, a gust of wind has been harnessed to power our homes and cities. The interplay of physics, engineering and natural forces in a windmill is truly a testament to human ingenuity. It's a complex process, but at its core, it's all about turning the power of the wind into something we can use. And that, my friends, is the marvel of engineering that makes windmills work. Windmills are more than just technological wonders. They represent a sustainable future. These towering structures, with their spinning blades reaching out to the sky, are far more than an impressive sight. They are a testament to human ingenuity and our commitment to preserving our planet. Windmills are a key player in the realm of renewable energy. As their blades move with the wind, they generate electricity without the need for burning fossil fuels. This is a clean, green, and endlessly abundant source of power. Imagine a world where the breeze that rustles the leaves cools your face on a hot day, or carries the scent of rain, also lights up your home, charges your devices, and powers your city. That's the world windmills are helping to create. And it's not just about the energy they produce. Windmills also play a critical role in reducing our greenhouse gas emissions. By embracing wind power, we can cut back on our reliance on fossil fuels, thereby reducing the amount of carbon dioxide and other harmful gases we release into the atmosphere. This is not only good for the environment, it's essential for our fight against climate change. Moreover, windmills hold the potential to power our future. As technology advances, so does our ability to harness the wind's power more efficiently and effectively. New designs and materials, along with improved storage and distribution methods, mean that wind energy could become an even more significant part of our energy mix. But perhaps the most important benefit of windmills is the message they send. Every time a windmill turns, it's a reminder of our capacity to innovate, to adapt, and to make choices that benefit not just us, but generations to come. They are a symbol of a sustainable future, where we live in harmony with our planet rather than at its expense. Next time you see a windmill, remember it's not just spinning blades, it's a symbol of our sustainable future.